Welcome in to the first video for lesson 2. Again, as with all our first videos, this will be just the content, and this will be the content video for exponents, for radicals, and then our first look at rationalizing fractions. Let me share my document camera here for you guys. Okay, so first, what is an exponent? What does it mean? What is our notation? So we have the definition that if A is any real number and n is a positive integer, then the nth power of A is notated as such. So we have this notation, and in this notation, the A is called the base, and the n is the exponent. And what this means is just A multiplied by itself over and over and over n times. So A times A times A times A, etc., etc. And I would have n of these. So if I had 2 to the third power, that would be 2 times 2 times 2. So it's not 2 times 3, it's 2 multiplied out 3 times. We have a couple special cases. So we have 0 and negative exponents. So if A is not 0 itself, then anything to the 0 power is always going to be equal to 1. And then if we have a negative exponent, so this is bad news. We never want to leave an answer that has negative exponents. So on a test, if it says, simplify this, don't leave a negative exponent, do not leave a negative exponent. To get rid of this is really like what? A to the minus n over 1. And so what we can do to make this positive is just bring this guy down into the denominator. And when we move it from the numerator to the denominator, or vice versa, so let's say I had 1 over a to the minus n, that's the same thing as if I take this up to the top, the exponent now becomes positive. So just a to the n power. So if we go from numerator to denominator or denominator to numerator, it makes the exponent, it changes the exponent, the sign on the exponent. We have our laws of exponent. So the first one, as long as my bases are the same, if I have a to the m power multiplied by a to the n power, this just becomes a to the m plus n. I just add the exponents. That was multiplication. If I have division, so a to the m over a to the n, this becomes a to the m minus n power. I have what's called the power rule. So if I have a to the m power and I raise the whole thing to the n power, now I multiply. the exponents. So if I had 2 to the third power to the fifth power, so i.e. 2 to the third all to the fifth, I multiply the exponents, so this is 2 to the 15th power. If I have a product inside parentheses, all raised to the nth power, and again, this is for product. This is not for addition or subtraction. So if I'm multiplying two things inside, I can just bring the exponent in to each term. Again, let me just point out one more time. That's for product, not for addition and subtraction. It works for fractions as well. So a over b to the nth power is a to the n over b to the n. Go up over here, so 6. So here is a property, let me put a little star by it, that we're going to use a lot in this class. If I have a over b, the whole thing to the negative n power, what I can do is just flip what's inside. So I don't change any pluses or minus on the inside. The only thing that changes is that the n on the outside now becomes positive. And again, this is one. So for my class anyways, on my midterms, I let you guys use a cheat sheet or a note sheet. You probably want to have these laws on there. Even if you remember them later, good just to have it quick access for yourself. So that's our exponents. For radicals. So again, let's look at a definition. So if n is any positive integer, then the nth root, so before we were talking about powers, now we're talking about roots. So the nth root of a is defined as, and now we have this notation. So this guy on the front here is the root, and we have all these invisible numbers in math, right? So if I have like x plus 3, I don't write 1x plus 3. It's just assume that there's a 1 there. Well, with roots, we don't write the 2. So if I have a square root, there's nothing written in front here. And then this guy underneath, and I'm going to write it in red pen because it becomes important later, is called the radicand. So whatever number is under the square root, under the root symbol, is the radicand. So if this whole thing is equal to some value b, what this means is that b to the nth power is equal to a. And so if n is even, then a must be positive, and that will give us a b value that's positive as well. So at this point anyways, we'll learn a little bit later in the semester, but I can't have like the square root of -4. So if I have an even root, square root, fourth root, sixth root, etc., then a must be positive. We had our properties of exponents. Now we have properties of roots. So the first one, is it the nth root of a times b? And I'm going to use double arrows here because I could either go from left to right or from right to left. But if it's written like this, I can break this apart as the nth root of a times the nth root of b. And similarly with fractions, if I have the nth root of a over b, I can break this apart as the nth root of a over the nth root of b. If I have the mth root of the nth root of a, this is the same as the m times nth root of a. And then the last property I'll show you here. So this one is probably the most important that we're going to need to know here out of these guys. We're going to use 1 and 2 probably the most, but number 4 is extremely important to know. And this is going from roots to radicals, from roots to exponents and exponents to radicals. So if I have a to the m over n power, whatever is in the denominator of this fractional exponent is the root. So this is basically the nth root of a all to the m power. Or you could also write it as the nth root of a to the m power. So either one of those. And so where this is important, and where we're going to see this a lot, so note, if I have square root of x, well, the exponent here is what? 1. So that's going to be in the numerator. And it's square root, so it's the invisible 2. So I get 1/2. So if I have to write square root of x as something with an exponent, it's x to the 1/2 power. Or conversely, if I want to get rid of any fractional exponents, x to the 1/2 power is the same as square root of x. All right. That's a lot of multiplication and division. What about addition and subtraction? So, down there. So when adding or subtracting radicals, the root and radicand, let me switch to red here, that's how important it is, must be the same. So I can't do square root of 2 plus square root of 3. Yes, they have the same root, but they don't have the same radicand. Or I can't do square root of 2 plus the cube root of 2. They're different. Think of it like variables. So square root of 2 is x, square root of 3 is y. X plus y, it's just x plus y. I can't simplify it any further. Now, a lot of times we could simplify a radical using our properties of roots so that we get the same root in radicand. But if they're not the same at some point, then we can't add or subtract them. And we'll look at some examples of that on video 2. And then finally, rationalizing. And we're going to look at 2 different types. So this first one is just, so rationalizing. So let me first say 2. So when we say rationalize, This is code for get rid of the radical. So if it says rationalize the denominator, that means get rid of the radical from the denominator. And the kind we're going to look at here today is just one term. So in, I don't know, lesson, let me check the schedule here. Lesson 5, I believe it is. We're going to look at when we have two terms, and there's a different methodology of how we would rationalize at that point. But when we have one term, all we're going to do is multiply the numerator and denominator by the root. So for example, if I have like 1 over square root of 2, and I want to rationalize the denominator, I want to get rid of the radical from the denominator. Well, what I can do, or what I will do, is just multiply the numerator and denominator by this root. So I get what? It's multiplying two fractions, so multiply the numerator, so I get square root of 2 in the top. And then here I have square root of 2 times square root of 2. So when we look at our properties of roots, we do what? As long as they have the same root, I can multiply the radicand. So 2 times 2 is 4. So I get square root of 4. And square root of 4 is what? It's just 2. So when I have square root, what I'm trying to do is break down this guy into groups of 2. If it was cube root, I would want groups of 3. If it was fourth root, I would want groups of 4, etc. And that's what I'd be pulling out. So since I have one group of 2, that's what I take out. So that's why square root of 4 is 2, because it's 2 times 2. The shortcut for this, when we have just one term, is to multiply, assuming we're rationalizing the denominator, multiply the numerator by the root, and then get rid of the root symbol on the bottom. On the denominator. So this is the mathematical way of doing it. But if we want a shortcut way, let's say I have, let's do, I don't know, 2 over square root of 3. Well, I could multiply the top and bottom by root 3 and then simplify from there. But if I use the shortcut, I'm just going to multiply the numerator by the root. So 2 root 3, and then get rid of the root symbol on the bottom. So it just becomes 2 root 3 over 3. So mathematically, that's the answer we're going to get to eventually, but the shortcut is to just do that. Move the root up to the top, get rid of the root symbol on the bottom. So that concludes the content for lesson 2. That was our exponents, our radicals, and our introduction to rationalizing. So come on back for video 2, and we'll work a bunch of problems putting this all to practice.